Okay, today we're going to look at complex numbers. A complex number is any number that can be written in the form a plus bi, where a and b are real numbers and I equals the negative or the square root of -1. So I squared is -1. That's very important to remember. So let's look at some things that we can do with this. If we have the square root of -9, well, this is the same as saying this is equal to the square root of -1 times 9, which is equal to the square root of -1 times the square root of 9, which is equal to I times 3. Now, we traditionally write this as 3I. Okay, here, same principle. Square root of -1 times 23 equals the square root of -1 times the square root of 23 equals I times the square root of 23. Again, be careful with this. Make sure your I is far enough out there. May even want to put brackets around it to be sure. Okay. Here, I have the square root of -1 times, and I'm going to go a little further, 25 times 5. Now this is the square root of -1. Oops. Square root of -1 times the square root of 25 times the square root of 5, which gives me I times 5 times the square root of 5, which is 5 times the square root of 5I. Okay, so now that we have the basis down, what can we do to this? Well, we can do addition, subtraction, multiplication, and division of complex numbers. Addition and subtraction are real simple. Combine the like terms. 2, 2. That's 7i plus 10i, simply plus 17i. Here we have two complex numbers, add in. Again, combine like terms. 3 plus 1, 4. 7i plus -2i plus 5i. That's it. Subtraction, same thing. 5 minus -3. Well, that's simply 8. -6i minus -5i, simply minus 1i. So next we look at multiplication. Again, same as with just regular numbers, distribute. So I have 7i times -2, which is -14i. Then I have 7i times 6i, which is plus 42i squared. Now remember, I squared is -1. So this becomes -14i minus 42. And again, the real number part comes first, -42 minus 14i. Please make sure you list it as a plus bi, because that otherwise I will have to take points off. Okay, again, multiplication. We go back to good old FOIL. First, outer, inner, last. In case you forgot. So we take the first times the first. 2 times -3 gives me -6. Outer times the outer, 2 times 7i plus 14i. Inner times inner, -5i times -3. becomes a positive 15i. And last times last, negative 5i times 7i is negative 35i squared. And don't forget to square that I. So looking at this first, we bring down this negative 6. 14i plus 15i plus 29i. And here I have minus 35 times I squared, which is negative 1. So negative 6 plus 29i, and this becomes plus 35. So I have 29 plus 29i. Oops. 29i. Okay, now we're going to square this. Well, again, since we're early on here, we'll just rewrite this like this. And then again, it's FOIL, first times first. 4 times 4 is 16. Outer times outer. 4 times negative 3i is minus 12i. Inner times inner, negative 3i times 4 is minus 12i. And last times last, negative 3i times negative 3i is plus I squared. So this is 16. Combine the like terms, and we have minus 24i, and this is 9 times negative 1, which is, of course, negative 9. Subtract 9, I get 7 minus 24i. Okay, so division is a little more complex than this. If we're talking about dividing two complex numbers, we need a quick definition. It's called the complex conjugate of the complex number, such as a plus bi, and it is simply a minus bi. So looking at these three choices here, essentially what we're doing is we're taking whatever the b term sign is and changing it. So in this case, we have 15 minus 7i. Here I have 1 plus I, and here I would have simply plus 3i. So here's the thing. In order to divide complex numbers, you must multiply both the numerator and denominator by the complex conjugate of the denominator. Okay? Probably want to go quite that big. So, complex conjugate is 3 minus 4i. Now, 3 minus 4i. So essentially I'm multiplying by 1. That's why we can do this. So let's put brackets around there, or parentheses around this, so we don't get messed up. So here I'm just foiling. Foiling the numerator, I have 3 times, or 1 times 3, which is 3. 1 times negative 4i, negative 4i. 8i times 3 is plus 24i. And 8i times negative 4i is negative 32i squared. Now coming down here to the numerator, or denominator, I have 3 times 3, which is 9. I have 3 times negative 4i, which is negative 12i. I have 4i times 3, which is positive 12i. And I have 4i times negative 4i, which is negative 16i squared. So you see what happens. The i's cancel each other out. That is the whole reason for doing this. So let's look at our numerator here. Bring my 3 down. Negative 4i plus 24i is plus 20i. This becomes negative 1, so I have plus 32. And here I have 9 minus 16i squared, which becomes plus 16. So I'm looking at 35 plus 20i over 25. Now, traditionally again, this becomes 35 over 25 plus 20 over 25i. And this can be reduced to 7 over 5 plus 4/5 I. I know the temptation is to leave it like that. But remember, complex number is a plus bi. So even though it's the same thing, go ahead and break it apart. Okay, let's look at another one here. Again, multiplying by the conjugate, we get -2 plus 3i over -2 plus 3i. Foiling, we get 1 times -2, which is -2. We get 1 times 3i, which is plus 3i. We get 3i times -2, which is minus 6i. And 3i times 3i, which is 9i squared. Doing our denominator, -2 times -2 is 4. -2 times 3i is minus 6i. -3i times -2 is plus 6i. And -3i plus 3i is minus 9i squared. Now looking at this, I have -2 minus 3i, and this becomes minus 9 over 4. The 6 i's cancel each other out, and this becomes plus 9. Then I have -11 minus 3i over 13, which is -11 thirteenths minus 3 13ths I. So looking at the powers of I, you'll see a pattern. I to the first is simply I to the second is negative I. So I to the third, I to the third is I to the second times I, which would be -1 times I, which is what we have here. And then I to the fourth would simply be I squared times I squared, -1 times -1, which is 1. And then that pattern repeats on and on. So looking at something like this, remember, I to the fourth equals 1. So this is I to the 16th times I squared. And I to the 16th is simply I to the fourth to the fourth, which means this is 1 and this is -1. -1 is our answer. Okay, so this here is I to the 36th times I. I to the 36th is I to the fourth to the ninth. Remember, when you take a power to a power, you multiply. So this is simply I. Now, looking here, how does this work? I to the -4th. Remember, this is 1 over I to the 4th, right? Plus 2I to the 11th. Well, I to the 4th is simply 1, so this is 1 plus 2 times, and that's what I to the 4th squared times, well, let's break this down. I to the 8th times I to the second times I. I have 1 plus 2 times I to the 8th, which is I to the 4th squared, times I squared is -1, times I. This is simply 1, so I have 1 plus 2 times negative I, which would be 1 minus 2I. And that's how complex numbers work, basically. We'll use this when doing square roots, because now we can do the square root of a negative number. That's it for this section. Have a wonderful day.